So before we start solving, let's kind of review a little bit what we did on Thursday, which was like looking at properties. So distributive, commutative, associative, and subtraction property of equality, addition property of equality, multiplication property of equality, and division property of equality. So here is an equation that is being solved. So I want you to look closely. What happened? What property was used to get from equation A to equation B? So what was used to go from equation A to equation B? Yeah, Asa?
Distributive.
Distributive property. Specifically distributing this 5 to the x and the 3. So that would be the distributive property. What about from B to C? What happened or what is different about equation B to equation C? Luke, what's different? Commutative. We went from negative x plus 9 to 9 minus x. So that would be the commutative property. And then from C to D, all they did was combine like terms. So 15 minus 2 gave us 13, and 2 plus 9 gave us 11. What about D to E? What happened from D to E? Yeah, Trey.
Subtraction property of equality.
Yep, so subtracting specifically 13, right? From both sides would be the subtraction property of equality. And then same thing on E, all they did was combine like terms. So 13 minus 13 is 0. 11 minus 13 gave us that negative 2. All right, what about F to G? Robert, what about F to G? Addition property of equality. You'll notice that they added x to both sides. So that is the addition property of equality. And then on letter H, all they did was combine like terms. 5x and x would give us 6x. Negative x plus x would be 0. And then last one from H to I. What happened, Asa?
Division property of equality.
Yeah, divide by 6 would be division property of equality, depot. When you're solving, I'm not necessarily going to ask you every single time, what properties did you use? But you do need to start noticing that I subtracted things from both sides. I added things to both sides. I used the distributive property. Those things need to at least be like registering in your brain what you're actually doing to solve these, okay? So we're going to create an equation from a word problem to start before we get a little bit more complicated. So a class is raising funds to go ice skating at a rink at Campus Martius in Detroit. The class plans to rent one bus. It costs $150 to rent a school bus for the day, plus $11 per student for admission to the rink, including skates. So what is the variable? What do we not know about the situation? Yeah, Henry? Yeah, we don't know students. So I'm going to say that X is going to represent number of students. So we want to write our expression for cost. So we know that we're paying for two things. We're paying for the bus, which is $150, plus, yeah, 11x, which is $11 per student. And then part 3 says the class raised $500 for the trip. So we know that this is going to equal 500. So I'll give you a moment. I want you to figure out how many students can I take on this trip if I have $500 to spend. So if I were to solve this, I would first subtract 150 from both sides to get 11x equals 350. And if I divide both sides by 11, I get, is it 31.81818181? Or 31.81 repeating. Same. Okay, so we're going to think logically. I can't take a 0.81 student, can't cut them in 0.81 pieces and take them on my trip. Do I take 32 students or do I take 31 students?
31.
Ooh, I hear both.
31.
Okay, hold on. So your whole life you've been taught if it's 0.5 or higher to round up, right? But we're talking about money. I do not have enough money to take a 32nd student. I only have enough money to take 31.8 students. So if I'm taking whole numbered students, I can only take 31. I can't take 32, although if this didn't have any context and I just said round, you would obviously round to 32. But since we have like a context here, we know that if we're dealing with money, we don't have enough money to pay for that 32nd student. So we would only have enough money for 31. Good. Okay, we're gonna look at a problem that's not necessarily in the book. So if you wanna write it on a sheet of paper, if you wanna write it somewhere in like extra space in the book, I don't really care, whatever is better for you. So go ahead and write down this problem. It says 2x minus 6, and then in parentheses, 3x plus 2 equals 50. All right, no, just let me get this out. Thank you. So this is a multi-step equation, meaning that it's gonna take more than 2 steps for us to solve. So for the moment, I just want you to ignore the 50. We're just gonna look on the left-hand side of that equal sign. We're gonna do all the stuff we can before we start even discussing the 50. So can anybody tell me something we could do on the left-hand side of that equal sign to simplify? Madison.
Distribute.
Yeah, we could distribute the minus 6. Oops, that was an accident. So let's go ahead and distribute that minus 6 to both of those things in the parentheses. So we still have 2x. Minus 6 times 3x would be minus 18x. Minus 6 times 2 would be minus 12. Still equals 50, but we're just not even gonna look over there yet. What else can I do on that left-hand side? Asa? Yeah, I can combine 2x minus 18x would be negative 16x minus 12 equals 50. That should look like a 2-step equation. Your goal is to get it to look like a 2-step equation, which is something we should be confident by this point in solving. So right now to the x, we're multiplying by negative 16 and minusing 12. So we want to do the opposite of those. So we first want to add 12. And that would give us negative 16x equals 62. And we want to do the opposite of multiply by negative 16, which would be divide by negative 16. And it does not end up being an integer. So I would leave it as 62 over negative 16. You can change it to a decimal. It ends up being a nice 3.875, negative 3.875, I think. You could simplify it to 31 over 8. I don't care, but just leave it. My advice would just, why wouldn't you just leave it as this equivalent fraction, improper fraction? But some people like to simplify, so whatever works for you. But all of this should be familiar. We've already done distributive property. We've already combined like terms. We're just now including that in our equation solving. So whenever you look at an equation, you want to see what kind of stuff can I do to each side first before I start moving things using the subtraction property of equality, using the addition property of equality. So we're gonna look at another one. Again, this is one that's not in the book, so make sure you have a space to be able to write it down. Says 2 times 4x plus 10 equals, yeah, Nihal, you'd have to write it like I did because your goal is to get x by itself on one side, okay, not having a coefficient. And then on the other side is 3 times 4x minus 8. So again, we're just talking about each side individually. What could we do to simplify one side or the other side in this case? Trey? Right, I could distribute 2. 2 times 4x would be 8x. 2 times 10 is 20. I could also distribute on the right-hand side, so let's do that. 3 times 4x is 12x, and 3 times -8 would be -24. I can't do anything else on the sides individually. I can't combine them like terms. I don't have anything to do. So here's my advice. You could do lots of things. I, Miss Simpkins, would move one of the x's to the other side. I would suggest you do the same. Another answer is not wrong. This would just be the most efficient way. But you can choose. Do you want to move the 8x or the 12x? Just pick one. It doesn't matter. Someone tell me. Okay, 12. I heard 12 first. So is it a positive 12x or a negative 12x? Positive. So if we're trying to eliminate a positive 12x, we want to do the opposite of positive 12x, which would be negative or minus. But remember, we want to do that on both sides of the equal sign. So what is 8x minus 12x? -4x. We still have plus 20. What happened to that 12x minus 12x? It cancels. And on the right-hand side, all I'm not left with is -24. And again, what does that look like? A two-step equation, which we should be able to solve. We want to do the opposite of plus 20, which would be minus 20. Close. So we have -4x equals -24 minus 20 would be -44. Simpkins. Hey, that's okay. Oh. Have they tried like shutting down the Chrome and opening it back up? I would like X out the whole window, maybe try that. I don't know. Yeah, and maybe if you like copy the page, like Control-C and Control-V into like their specific notebooks instead of distributing, that might help too. Do you know what I mean by that? Yeah. Yeah, for those kids that it's not working for, maybe just like copy it to them. Okay. Okay, no problem. Bye. So we want to divide both sides by -4. So X would equal 11. X equals 11. We're going to be practicing this a lot, but you just solved an equation with variables on both sides, which is exciting. Woohoo! Yay! Yay! Okay, I'm excited. All right, so we want to look at number 1 under the Let's Practice. This one is in your book, so go ahead and find that. And it says 2x minus 3 times 2x minus 1 equals 3 minus 4x. So again, can anybody see anything we can do on one side or the other? Henry? Okay, we want to distribute -3. So let's do that first. So we still have 2x. -3 times 2x would be -6x. -3 times -1 would be +3. And then on the other side, we have 3 minus 4x. Is there anything else we can do on one side or the other before we move on? Yeah.
Combine like.
Right, I can combine 2x minus 6x to get -4x plus 3 equals 3 minus 4x. Do you want to, okay, so we're done on each side. So let's talk about our variables. Do you want to move the -4x or the -4x? Sure. What's the opposite of -4x? Plus 4x. Uh-oh. What happens to all my x's? And I'm left with no variables, and I'm left with 3 equals 3. Is that true?
Yes.
It is. Since it's true, and I have no more variables, this is a situation where all numbers would work. I could substitute any number in for x that I would want to. The way you would say the answer, though, you may see it in a couple different ways. The most popular way, my preferred way, is to call it infinite solutions, and you can denote that by literally just drawing the infinity symbol. So what that's telling me is any number that I want would work for this problem because I end up with the same number equaling the same number. You could also see it written like this, an R with like 2 stems, which means all real numbers. Or some people write out all real numbers. I don't care out of those 3, whatever way you prefer is fine with me, but you need to make sure that you recognize the other ways of how we would say this answer. So it's either infinite solutions, all real numbers, or writing out like the words all real numbers. Cool? Okay, let's try the next one. So does anybody have a suggestion on what I could do to start this one? What could I do on one side or the other first? Okay, I could distribute the 3. So 3 times 4x would be 12x. 3 times 1 is 3. What about on the right-hand side? Do you see anything I can do on the right-hand side? Robert, what can I do?
You can subtract.
Okay, what?
Or add the 3 and then
Okay, so combine like terms. Are you okay with me saying it like that? Okay, so I could add or subtract 3 minus 5, 3 plus negative 5. It's all the same. But I would end up with 12x minus 2. Well, do you want to get rid of the 12x or the 12x? It's a tough decision. I would say the 12x. It doesn't matter which one. The opposite of positive 12x would be minus. And I end up with 3 equals negative 2 because all my 12x's disappear. Does 3 equal negative 2? Bless you. No, because that's not true. There is no solution. There is no number that I could substitute in for x to give myself a true statement because we ended up with no variables and 2 numbers that were not the same. So we call that no solution. Please do not write this because what does that look like? X equals 0 and x doesn't equal 0. There is just no solution. So we will denote that with either a 0 through a cross with a cross through it, or you can write out, oh, that was not how you spell solution. Solution. Yeah, so Nihal, when there's no answer, you just do a 0 with a line through it, or you can write out the words no solution. I don't really care either way. So think about those 3 situations. Our first situation is when there's one answer, okay, like on number, or the one you wrote down, which the answer was, oops, come on. What was the answer to that one? 11. We can have an infinite amount of solutions when you end up with the same number equaling the same number. Or you can end up with no solution when you have 2 different numbers equal to each other. So here's what I'd like you to do. I'm going to give you 3 problems. Oh, sorry, Madison, what's up?
No, I was just stretching.
Okay, cool. On the last one we did, Tatum, the one we just did. Hold on one second. Yeah, no, there is no number, Tatum, because you didn't end up with a variable. So we can't say that the variable equals anything because our variables cancel. So we can just say that any number works if those happen to be the same number, but since they're not, we call that no solution. Okay, so I want you to work out these 3 problems. Again, you can do them on your sheet of paper if you find space in your book. I don't really care, but let me know when you're done because I want to check them. And same digital students, send me all 3 of those answers when you're done with all three.